Okay, here's the question then. So let's have a look at it. I've got it summarized here. So the range of G, first of all, is what it's asked for in part A. So the range of G is equal to, okay, kx minus 4 goes from 2 to infinity. K is positive, so there's a straight line increasing. So its biggest value will be infinity, and its least value will be when x is 2, so it's 2k minus 4. It includes 2, so it will include 2k minus 4. But then the straight line will just increase without end, won't it? Because it's a positive gradient. So that's the range of G. Part B, find the least value so that F composite G can be formed. So for F composite G to be formed, the range of G must sit inside the domain of F. So the range of G is 2k minus 4 to infinity must sit inside the domain of F, and the domain of F was minus 2 infinity. So that, therefore, this value must need to be bigger than or equal to this value. So 2k minus 4 needs to be bigger than or equal to minus 2. So 2k is greater than or equal to, move that over, 4 minus 2 is 2. So it tells us that k is bigger than or equal to 1. So k needs to be bigger than or equal to 1. And what is the F composite G in part 2? Let's just remind ourselves of the fully worded question. F composite G then is equal to F of G of x, assuming k is bigger than or equal to 1. G of x will be kx minus 4. F and f of kx minus 4. F sends something to something squared plus k times something plus minus 8. Something squared plus k times something minus 8. Let's just check that. Something squared, k times something minus 8, and the something in this question is kx minus 4. Kx minus 4. Expand the bracket, we get kx times kx minus 8kx for the two middle terms plus 16 plus k squared x minus 4k for these two minus 8. So what do we get? We get k squared x squared minus 8k plus k squared, lots of x. So that's that one, and that one. Then we've got 16 minus 8 is 8 minus 4 the 4k. And there's the F composite G function in part 2. Now we're told fg of 3 is 0. So F composite G of 3, 9 k squared plus k squared, 3 of these, 3k squared, and 3 of these minus 24k. I've expanded the bracket as well, plus 8 minus 4k. Fg of 3 is 0. 12k squared is that one and that one. Minus 24, minus 28k plus 8 equals 0. So there's a 4 common, isn't there? 3k squared minus 7k plus 2. So if it factorizes, it's got to be 3k and k. It's got to be 2 and 1. The minus and a minus, isn't it? 3k squared minus 6 minus 1 plus 2. So this one is k equals 1/3, and this one is k equals 2. So since k is bigger than the one value, so k must equal 2. Okay, that's what we get for our solutions then. So let's go back to the past paper. k is 2. We get this, which is what we must have had. K is bigger than or equal to 1. The least value of k is 1. Okay. So the least value of k is 1. So in part B then, if we look at the question in full, find the least value of k. So in B part 1, the least value of k, which I should have written down, so that this composite can be formed, part 1. So that tells us k equals 1 here would be the least value. So put that answer in now. Okay, good.